Today we're going to talk about linear regression and one of the drawbacks of it in terms of interpretability. In the future we'll talk about regression trees and decision trees and how they are more interpretable than linear regression, at least in some cases. Alright, so to start off, I'm going to just simulate a data set within R. So these first 4 lines of code here, they just create this data set D that has 3 columns of independent variables and 1 column of a dependent variable that I want to model, let's say. In linear regression we can have any kind of variable types. Here we have one that goes from 1 to 10, one that's random normal data, and then one that says random count, and then our y value is also random normal data. Now, to fit a model, we would run a function like this, and this model is saying I want to estimate y, and I want that to be a function of x1, x2, and x3. And then by putting these multiplication signs between them, I'm saying that I'm going to allow x1 and x2 to interact, I'm going to allow x2 and x3 to interact, and I'm going to allow x1 and x3 to interact. So now let's run it. R fits the model, and then we can take a look at what this model is, what the coefficients have been estimated as. And what we see here is the estimates for the coefficients, and it's maybe a little bit difficult to interpret because now we know that this coefficient means that if I change x1 by 1 unit, then y changes by minus 0.002 units. Okay, that's fine. If I change x2 by 1 unit, y changes by this much. Those all make sense. But then now we also have these interaction effects that we have to think about. And so now if I change x1 by 1 unit, and if x2 is 1, then the effect on y is this minus 1 times this. So that gets a little complicated to try to start thinking about and understanding what that relationship looks like. And then also, if I change x1 by 1 unit, and x2 is 1 and x3 is 1, then I'm changing y by this amount as well. And so it gets very difficult to try to understand all of these complexities and all of these interactions between variables. And moreover, it's important for us to, in linear regression, it's important for us to specify the relationships that we think will be in the data set. So we have to tell our model that x1 and x2 should have an interaction term and that they should both be linear, and we kind of have to provide that nonlinear relationship. In some cases, maybe our data doesn't really support much nonlinear relationships, and so that doesn't really matter, but in some cases it becomes very difficult to fully specify the relationship that we're looking for. So we'll see in a few lectures how decision trees handle this topic, and I think they do it fairly well.